Okay, so this video is going to work through problems 1 through 5 on the review. This review is going to be posted on Delta Math. It's going to be titled, let me see here, let me make sure I'm talking about the same thing. It's going to be called 5-3 Review. So as you need to watch and have questions on different problems, just work through the Delta Math as much as you can, then come find the problem on here. So 1 through 5 starting now. The first one says, simplify the expression as completely as possible. So on top, you just need a factor. So on top, it's going to be difference of perfect squares. So x plus 7, x minus 7. Okay, because the square root of each one of these, and then you're going to put it into the plus and minus. And then on the bottom here, you're going to do the x method. So 4 and negative 21, that is 7 and negative 3. So what adds the 4 and multiplies the negative 21? I write that out, x plus 7, and then x minus 3. You cancel out what they have in common, and then I'm left with x minus 7 over x minus 3. Okay, I'm gonna move in quick. You can go back and rewatch the videos as needed. So this one says just perform the operations, so basically divide, and remember, to divide like these fractions like this, all you're going to do is flip, or I guess the way that you all have learned it a lot is keep, change, flip. Keep, change, flip. So you're going to keep the first one, so 3x squared over 3x. You're going to change the division to multiplication, and you're going to flip the second fraction. Just switch the numerators and denominators. Over x squared plus 9. Now, when you're writing this out, you're going to have to factor out as much as you can. These are both monomials, just leave them like they are. And you're going to have right here in blue, I'm going to point my arrow to it, you're going to do the x method again. So negative 10, 21, it's negative 7 and negative 3. So I'm going to have x minus 7, x minus 3. Going ahead and writing that as one big fraction. And then here, what I just pointed to, x squared minus 9, that's difference of perfect squares again. You know that because it's x squared minus a number. Anytime you have x squared minus something, that's what you should think of. So x plus 3, x minus 3. Now, let's factor it out as much as we can. So we're going to go to the cancel mode. So we cancel these they have in common. And then here, the 3 divided by 3, those can cancel out. And then I've got x squared and x. So I'm going to be left with x on top after I cancel out one of these. So boom, and I'm just left with 1 on top. And then I'm going to have x minus 7 and x plus 3 as my final answer, okay? And you can leave it like this right here if you need to. Like, that's totally okay. Next one, it says fully simplify the expression and write your answer as a single fraction. So all this is going to be is just doing a lot of factoring. So when you multiply, just put it all together as one fraction and cancel out from there. So first thing I got to do on this first one, so we're going to bring out 2x to the third. That's what this one has in common. And that leaves me with x squared minus 25. Oh, x to the third. Yep, x squared minus 25. Okay. And then I know that I can go ahead and simplify this to 2x cubed, x plus 5, x minus 5. Okay, so this is my big fraction here. And then for this part right here, I'm just going to go ahead and combine these two together. And this x squared minus 81 is going to become x plus 9, x minus 9. This part that I'm pointing to in black is going to become the x method. So 4, negative 45, 9, and negative 5 do that. So that's going to give me x plus 9 and x minus 5. And then this guy right here is going to be a two-stepper because I have to factor out the 6 that they all have in common first. So I'll draw that right here. So 6 is with x squared minus 4x, then 270 divided by 6 gives me 45. Huh, that's kind of weird. So x squared minus 4x minus 45. Okay, and then I know that that can break further down into 6x plus 5, x minus 9 from the x method, because it adds to negative 4 and multiplies to negative 45, so that leaves me with 6 x plus 5, x minus 9. Okay, so that was a lot. But now, let's go through and cancel out everything that we can. I have an x plus 5 here and here, x minus 5 here and here, x plus 9, x plus 9, x minus 9, x minus 9. So, everything cancels out except for 2x cubed over 6, and 2 over 6 simplifies to 1 over 3. And technically, I don't need that 1, so I can write it just like this. Either one of these two would be acceptable though. So now, 4, we're working with combining fractions, so we're adding fractions, but we always have to have, we need to get to a common denominator, right? 6x and 4x aren't common, so we need to find our LCD, or least common denominator. So when I'm looking at this, what I'm looking for is, what's the smallest thing that they have in common, okay? I know I'm gonna need an x. And then 6 and 4. What's the smallest number that 6 and 4 have in common, okay? The multiples of 6 are 6, 12, and 18, 24. And then for 4, it's 4, 8, 12, 16, okay? And right away, I already see that I have the smallest in common is going to be 12. So it's going to be 12x, which is made up of 6, or 12x is made up of 2 times 2 times 3, okay? Times x. So when I break this apart, I'm going to have 1. I know I'm going to have over 12x for both of these. Okay, that's the whole point. And now, when I look here in red, 6x, what do I need to multiply 6x by to get to 12x? Well, it's missing one of the 2's here, okay? So I multiply the bottom by 2, so I'm going to multiply the top by 2, okay? And then for the blue, what's 4x missing? How do I go from 4x to 12x? Well, I'm going to multiply by 3, so I'm going to have 5 times 3. And it's going to give me 2 over 12x plus 15 over 12x. Now I just add the tops. You do not add the bottoms. The bottoms tell that you can go together. So 17 over 12x is going to be my final answer. Okay. Last one. So when I write this out, what I'm going to have to do is to find my LCD, my least common denominator. I've got to look for what's the smallest thing they have in common. Well, here, when they're completely different like this, it's a little weird. So I've got to come in and say, well, I know I need x minus 6, but I also need x plus 5. So really, the least common denominator is just going to be exactly that. Those two multiplied together. Because I need both, and they don't really have anything in common for me to simplify. So, let's write this out then. So I know I'm going to have two fractions with x minus 6, x plus 5, plus x minus 6, x plus 5. So this first fraction in red is missing x plus 5, so I've got 7x plus 3, and I'm missing x plus 5. And then on this one, I've already got to 3 here in blue. So I'm got a 3, and the bottom here is missing x minus 6, so 3 times x minus 6. I can do box method on these. So 7x plus 3, x plus 5, so 7x squared, 3x, 35x, and 15. Okay, so when I box method those out, that's what I end up getting. And combine my like terms across the diagonal gives me 7x squared plus 38x plus 15. Then over here, I've got, just write it out. I just distribute this 3, and I've got 3x minus 18. So when I make these one big fraction right here, when I combine these like this, all I've got to do is combine like terms. So I've got 7x squared, and then these guys. So 38 plus 3 is 41x. And then 15 plus negative 18 is minus 3. Okay, and you might be tempted here to slide and divide once you have this, see if I can factor out and get anything, but that's going to give me, like, my slide and divide is going to give me that it adds to 41 and multiplies to negative 21, and that doesn't exist, so this guy right here is going to be your final answer. Okay.